Hello, we're going to talk about oxidation states of carbon and how is it different to formal charges. So let's get started, and we're going to draw methane here. And later on, we're going to see reactions which involve oxidation state changes in carbon. So it is important that we know what's going on with the oxidation states of carbon. So when we did formal charges, we did the following. First, for the formal charge, we need to know the valence electrons. So we know that carbon has 4 valence electrons. Also remember that you can go to your periodic table, and the number of the group that is on top, it tells you the number of valence electrons. So it is 4 valence electrons. And when we did formal charges, we subtract here the number of electrons in bonds, and here I have 2, 4, 6, 8, and we divide it by 2. And then we add the number of electrons in lone pair, but we don't have any here. But what I want you to notice is that when we do this, we count the number of electrons in bond and divide it by 2. We're saying that the 2 electrons are equally, say, belong to the 2 atoms. So split in 2. So they are not assigned to either one. They just split in 2. This is what we call homolytic cleavage, for example. It's as if we consider breaking a bond, but just 1 electron to one side and 1 electron to the other atom. That we study in that type of cleavage when we study radical reaction. But the point is that we consider those electrons in bonds equally shared by the 2 electrons. And we say that the formal charge of a carbon is 0. Now, when we do oxidation states, we're going to take into account differences in electronegativity to assign those electrons. And this time, the electrons in bonds, we're going to taking this into account, we're going to consider as if the bonds are broken or cleaved heterolytically. Heterolytic cleavage. What is that? Cleavage is breaking bonds. So now, what are we doing now? We're going to draw methane. And if you go to your periodic table and see where are these atoms, we know that carbon is more electronegative than hydrogen. And so when we do this, taking into account this difference in electronegativity, when we do the counting, we're going to say that the bonds are going to be assigned to the more electronegative atom. Between these two electrons are going to be assigned to carbons. Also this 2, this 2, and this 2. And now when I do my math, I'm going to say that the oxidation state of that carbon is, and I again go to my valence electrons, 4. And now I say minus, and I count how many electrons are assigned to carbon, taking into account that difference in electronegativity. So we say 4 minus 8, 2, 4, 6, 8. So the oxidation state here is -4. Notice the difference between them, formal charge and oxidation state. And in general, we say that a carbon atom like that with 4 bonds, we will have always a formal charge of 0. So we're going to work more examples on that. Let's do another molecule. For example, I'm going to change one of the hydrogens by, say, an oxygen. And so I am going to draw oxygen here. And what I'm drawing here is methanol. And again, for the oxidation state of carbon, again, we're talking about carbon. Well, we'll start from the valence electrons, but then opposite to formal charge. Now we're considering the bonds, the electrons in the bonds assigned to the more electronegative atoms. So here, between oxygen and carbon, oxygen will take the electrons. It is more electronegative. But between carbon and hydrogen, then it's carbon. This 2 will be assigned to carbon, this 2 as well, and this 2 as well. So now the number of electrons assigned to carbon is 2, 4, 6. These are assigned to oxygen, so I only count 6. So here, the oxidation state is -2. But it's still formal charge here is 0. If you did the math, again, in this compound, formal charge of that carbon, you would say 4 minus, and then you count the electrons in bonds and divide it by 2 to 4, 6, 8. So you will do exactly that. So all these compounds having a carbon with 4 bonds, you're going to have 0 formal charge. But oxidation state will vary. We'll do more examples.